Hello and welcome back to another VMK in the C++ series. In this VMK, I'd like to introduce the C++ coding style that I'm going to try to stick to from this day forward. So let's go into Visual Studio and take a look at some sample code. Every file that I'm going to create will have a header at the top, which will contain a version number, the copyright notice, and my email address. Below that will be any include files, and then below that will be any source code. Now the source code will be formatted in a specific way, or at least I'll try to maintain it in this kind of format. Anytime that there's a bracket, I'll introduce a space before and after all the variables within it. If there's no parameters being passed in, then you'll see an opening and closing bracket with no space in between. For functions, the opening brace will stay on the same line as the name of the function as shown here. And for variable names, for instance, if I create a class named myClass, the class name will always start with a capital letter, and the variable that uses that class will always start with the lowercase letter, and its name will be the same as the class name. Let's take a look at myClass. This is where you'll see most of the major changes that I've made. Again, we have the header information at the top. If not defined, define the class so that we only compile this code once whenever we include it into different parts of our code. The definition will be the same name as the class _h, and right at the very end I'll always add in a comment to describe what is this end if for, and you'll see that this end if basically matches up with this one here. Inside of here we have typically include stdafx.h for our precompiled headers, which I'll show you in a minute. And then we have a class definition. Now previously, what I would do is I would place my variables below my functions. I've swapped this around because as you code more and more, you'll notice that there become this dependency on the variables and some of the parameters that you pass in. For instance, if you have an enumeration, you typically need to declare it before the class that uses that enumeration, or you need to create a prototype. So to avoid having to write out extra code for your prototypes, I've just swapped these around so now the variables will be at the top and the functions will be at the bottom. As always, I've broken up the variable section into public, protected, and private, and same thing down here inside of the functions. We have public, protected, and private. And inside of the public section, this is where you're going to be placing all your enumerations and structures that you want to be stored inside of your class. You could store them outside of your class if they're very general, but if they make more sense to be grouped with your class, then you'll be placing them inside of the public section if you want them accessible publicly. Otherwise, you'll be putting them down here into either the protected or private section. The protected section, this is where all the member variables will go that you will want to inherit into other classes. And if you are not going to be inheriting, then all your member variables should show up inside of the private section. You should never put any member variables in the public section because basically you're exposing those variables to the outside and there's really no reason to do that. The reason why you're creating a class in the first place is so that you can have this protective structure around your variables. So you don't want to be putting variables in here. Part of the new coding standard that I'm going to be using, I'll be changing the way that I name my member variables. Previously you would see things like this, mi_int. What I've decided is I'm just going to be dropping the m part. It's just an extra character that you need to type, and there's really no reason for it. So all member variables will now start with just an underscore rather than an m underscore. Static variables I'll still label as s underscore, and then the variable name, just so that I know that that's a static member variable. Down here inside of the function section, all classes will have a constructor and a destructor. If this class will be inherited into other classes, then you'll want to make sure that you add in the virtual keyword in front of the destructor, or else you'll have problems cleaning up your classes. Again, protected, if you want any protected functions that go here. All classes will contain a copy constructor as shown here, as well as an overloaded operator equal function call as shown here. This is primarily to ensure that when you're trying to construct classes by equating two things together or trying to construct a class from another class, that you won't be stomping on your dynamic memory. So let's play with this class for a little bit to see what other things I've decided to change. To make this a little bit more interesting, I'm going to add in some member variables in here, so we do have something to play with. I'm going to create a new enumeration, and I'll put it here into the public section. Enumeration names are going to be the same as class names, always starting with a capital letter, and the actual values within the enumeration will be all capitalized. The first one will always be initialized to a specific value. Typically it will be 0 like shown here, but it could be something else depending on the way that I intend to use the enumeration. Then down here in the private section, I'm going to add in the following. I'm going to have a character pointer, an integer, a boolean, a float, and also one of these guys up here which I just declared. So as you see, all of them are going to have an underscore as the very first letter in their name, and then the actual variable name. I like to pre-append my variable names with an identifier so that I know just by looking at the variable what kind of type it should be. In Visual Studio, when you do highlight over it, it does tell you what that variable declaration is. So here I can see this is a boolean, this is a float, and so on. However, if you were to print this code out, or you don't want to be using your mouse to highlight over a variable name, you can still tell what that variable represents just by looking at the characters. Now, the letters that I'm going to be typically using is P for a pointer. That could be pretty much any kind of pointer. I for integers, B for booleans, F for floats, and other common ones that you'll see me use is SZ for a string that has a 0 or null terminator at the end, D for doubles, and I can't think of any else off the top of my head. But basically those are the standard pre-appended characters that I use in my variable names. The actual variable name will be lower camel case, which means that each word within the variable name will start with a capital. So for instance, if this was something else like I number of cans, I would write it this way. So num starts with a capital, then I have lowercase, O capitalized, lowercase, C for cans capitalized, everything else lowercase. So that just makes it a little easier to read as you're looking at the variable. Okay, so I've declared that, and let's add in a few more functions here as well so I can demonstrate how I plan on declaring functions and spacing things out. Speaking of spacing things out, when I declare variables and functions, I'm going to try to align them so that they all align like this. However, if I do have things like maybe I have a long variable, and if I were to do that, it doesn't quite align. In that case, what I'll typically do is just take that out and put it in its own block with a space in between. So here we see we have this one, maybe I'll have another one, another one. So these ones line up with one another, and then these ones here line up. Let me just undo that. Same sort of thing you'll see here inside of the declarations of functions. Actually, I want to make these functions public so I can actually call them. I'll create a function, an inline function called calculate. I'll create a getter and a setter for our string. Now again, if I'll try to align the left side of the functions so that they line up like this, which means sometimes I'll need to add in some extra spaces to compensate for whatever the return type is. If there's parameters being passed in, then I'll have a space around the brackets and then declaration of the variable within it, like so. Anytime that a function gets called but does not change any of its member variables, I'll use the constant. This just ensures that this function here cannot change any of the variables that are contained within my class. Also, if I'm returning a pointer to something that's contained within my class, I'll always try to declare it as a constant pointer, thereby preventing the user who gets that pointer from changing my internal variables within my class. These are just protective measures so that if someone unfamiliar with your code tries to use your own functions, they'll have a more difficult time breaking your code when using your functions. Inline functions will always be declared underneath a class unless there's a whole bunch of them, in which case I'll create a inline file and include it into my class definitions. So for this one here, I only have one inline function. I'll just write the source code for it right down here below. And the calculate function, it's going to basically calculate some number here. I have this be valid variable. So if the be valid variable is true, I'm going to take the floating point number, multiply it by the integer number, and return that out of the calculate function. Otherwise, I'll just be returning -1. This is just some made-up function. Doesn't really mean anything. Also, let's take a look at myClass.cpp, where I've defined the constructor, destructor, and these functions here. Every function that I declare will have this separator here and then a small comment. This will just make it easy for me to spot where a function begins and where a function ends. Also, every function that I create will have a closing comment here at the closing brace so that I can quickly scan and see what does this function represent if I'm scanning from bottom to top. So for instance, here, if I'm scanning this way and I just happen to do something like this, I can see that this part up here belongs to my constructor. This is very handy for myself whenever you're creating long CPP files that have a lot of code between the declaration and the closing brace. Another thing you can always do though within Visual Studio is just click within one of these, and up here it should tell you which class you're inside of. But again, that's an extra step that maybe you don't want to go through the process to figure out what is this function without having to click on the actual internal part of that function. Okay, so going back to the constructor here, all member variables contained within a class have to be initialized within your constructor. So the way that I'm going to be initializing all my member variables, that I can anyway, is by initializing them this way. As a class constructor is constructed, we're passing in all of the variable names here and then passing in some default values that they should be initialized to. So here I value is being set to 2, b valid is set to true, f value is set to this value here. Size is that enumeration value. I'm setting it to small. Remember back here we declared this enumeration. And p string, I'm initializing it to null. You can't initialize all your variables this way. For instance, if you had an array, then you couldn't do this. So in that case, you're initializing them down here between the braces of your constructor. But typically, if there's no other dependencies, no other extra work that needs to get done, then all you would have is your initialization of your variables, and then your actual constructor would be blank. The destructor always has to clean up any memory that is allocated dynamically within your class. So in my class example here, we have a pointer to a string, and I intend to create some memory dynamically when I set the string here. So when the destructor gets called, we need to clean that up. I'll create a function called saveDeleteArray, passing in the pointer to our string, and that function is going to be responsible for cleaning things up and reinitializing this guy to null. The setString function, what it does is you pass in a string, and it's just going to set the member variable of that p string variable to whatever we pass in here. So first we need to clean up anything that's previously in there, figure out how long the string is that we passed in, add 1 to it so that we have space for the null terminator, and then I copy over the string's value over into our member variable. So that's all that does. Lastly, we have getString, which is going to return a pointer to a character array, and the pointer is the p string that we're storing inside of our class. If we open stdafx.cpp, you'll see that I'm including stdafx.h, which is my precompiled header. stdafx.h, and we see we have the following. These are some of the include files that were included when Visual Studio created this sample file for me. Oh, I forgot one other thing. Inside of the project settings, under General, I typically don't compile anything under the Unicode character set. I always use multi-byte character set. So if we change that over, let's just do a clean solution and rebuild. And there we go. We see that we are now able to build. What else? Oh yeah, so saveDeleteArray, going back inside of stdafx.h, this is where I'll typically declare these two functions. I use these so heavily that I need them pretty much everywhere. So I place these inside of stdafx.h so they are accessible from anyone who ever uses the precompiled headers. All we do with these two functions is we pass in either a strict pointer or a pointer array, and we call delete on that pointer or delete with the brackets on that pointer and then set that pointer equal to null. So that's what we're doing over here. All right, now that we have this class, let's go into our main and give it a try here just to see how things are working. Okay, so here's some sample code. All we're going to be doing is setting the string to matic.com, displaying the calculated value, and here I have an if statement that decides whether we want to set the string to null or set the string to matic. The other thing we have here is the execution of the getString function call, which is going to get our pointer, which we can then display this way. If I run this through Control F5, we see we get the value 3.14 displayed and then my name displayed. So things I want to point out here, the use of the if statement and if else. The coding style that I'm going to use is taking the else and I'm going to place it on the same line as the original if closing brace. I also will typically add a blank space before the end of a closing brace for a section. I just find that is a little bit easier to read the source code if it is written up that way for myself. Now, going back to what I was saying earlier about these constants, here for instance we see we calculate some value here inside of our calculate function. If I were to try to change one of our member variables, like for instance let's take this one here and try to set this equal to false, and if I were to try to compile that, the compiler will fail and say cannot be modified because it is being accessed through a constant object. So this constant is basically preventing me from changing any of my member variables within my class. If I remove that, then I'm basically allowing that function to make changes on my member variables. So that's an extra protection that is handy to have inside of your classes when you are defining your functions. The other constant here is this one that I talked about earlier. If we go back inside of the main function, we can see I can compile this. It compiles fine. However, if I wanted to change this so that here I'm getting a pointer to that string, and let's say I wanted to change the very first character of my name to, I don't know, J. This would be a valid line of code. However, if I try to compile that, you see you can't do that because the variable is assigned as a constant. And if I were to remove that and try to compile this, then you see you get another error message saying cannot convert constant character pointer to a character pointer, because this guy here is returning a constant character pointer. So again, if we were to go back and remove this, now you can see what can happen. If I press Control F5, I forgot to remove the constant here. Okay, so now if I go and press Control F5, you notice that I've actually am able to change the first letter from an M to a J. And that's pretty painful considering that you shouldn't be able to change member variables within our class. So if I were to go in here and create a breakpoint and take a look at my member variables for my class, let me close this off, make some more room here. You see that the p string value inside of my class has actually been renamed to Yatic rather than Matic. So I was able to set a different value within my class through the use of this external pointer. So that's dangerous. You don't want to do that. Anytime you are returning pointers to internal variables within class, you do want to make sure that they are all constant. I think that's pretty much it. So there may be other minor differences between my coding style now and the ones that I was using previously, but for the most part, things will be pretty much the same. If you have any questions or comments about this VMK, feel free to post them on the forums under the appropriate forum thread, which you can find by clicking on the thread URL beside each of the VMKs.